All right, welcome back, everybody. This is Professor Dowd with just a very short lecture video this time on like a very kind of small aspect of stereochemistry for now. Just kind of a new way to represent molecules that have chiral centers, which is called the Fischer projection. And this Fischer projection, we're just covering section 5.7 on Fischer projections. It's kind of an oddball section here. It is extremely useful when you have like a bunch of chirality centers in a molecule, but most of the time we're not going to be using it for the molecules that we're talking about. Next semester, when we learn about carbohydrates, Fischer projections are going to become very important. So it's important now. And the way that you read them is basically, the Fischer projection is like a flattening out of a chiral molecule, where the central carbons, they're in the middle, and it's like a big plus sign. And then basically the way it's organized is the vertical lines, the ones going up and down, are going into the page, so coming out towards me. And then the ones that are horizontal are both coming out towards you, so coming out of the screen that way. And that's just how you organize it. You think of like, okay, I'm going to take this chiral center, organize it in 3 dimensions so that the ones coming out of me are on the horizontal line, and the ones going into the page or into the screen are vertical. So again, it's not particularly useful for our sake, but it is very useful in the future when we look at carbohydrates, because these are examples of sugars here. So you can have sugars that have 2, 3, or 4, or even 5 chiral centers. So it's important to note where they are. And it's hard keeping track of all of those in a 3-dimensional notation. So this is just a kind of a way of showing them. So this is one way that we represent sugars in the future. The other way that it's really easy is actually it's very helpful when you want to figure out what's an enantiomer and what's a diastereomer. So if you flatten everything out in a Fischer projection, you can see right away, oh, is it a mirror image? And these two are mirror images. Clearly they're non-superimposable, so they are enantiomers. Whereas here, we just flip one of the chiral centers, so they're not mirror images, yet they are still stereoisomers, so these are diastereomers here. So we have a little bit of practice down below, but that's all I really needed to say about Fischer projections. Practice reading them, and then once you kind of have a good handle on how to read them, just kind of store it in the back of your brain. We're going to have like maybe 1 question on the test, but it won't be a big section on this upcoming test, so don't worry too much about that. And we're going to move on to the next lecture. See you in a bit.